Since I participated in yesterday's codechef starters 141 contest. In this video, I'm going to recall how I approached the problem, how I solved the problems. First problem, the free clover. Chef said that four-leaf clovers bring good luck. So he went looking for one. In research, Chef found n clovers in total. Out of them, exactly one was the four-leaf clover, and all the other were three-leaf clovers. How many leaves did Chef collect in total across all the clovers? So he told that he found exactly one clover which has uh, four leaves, and remaining all have less than four leaves, like three clovers, and others will have three clovers. So it is just a simple mathematical equation. So, uh, we have to take uh, care of how we need to read input and output. The only line of input will contain a single integer n. So that means we have to take a single integer and we have to read that n. And for output, print one integer, the total number of leaves chef collected. So we can directly write like this. So we have to print a number of leaves that chef has collected. So we know that n minus one leaf have those n minus one cloves have three leaves, and remaining one clove has one leaf, isn't it? So problem solved. Successfully executed. And then reset mission. Oh, this is about the first problem. Now second one. It's about nearly equal. Like we have to put some brain here. It's going to take my remaining time in the context. That's why I just only solved two problems in yesterday's context. So nearly equal. So the Hamming distance between two pairs of strings of equal length is defined to be the number of positions at which they contains different characters. For example, the Hamming distance between the strings there and share is 2. Why? Because these there, the first character in first string, the first character is string, and in the second string, the first character is s. And in first string, the third character is E, and in second string, the third character is I. So, and remaining all characters in these two strings are equal. So, only we find two strings, two characters of those two strings, which has different characters. So, the Hamming distance for these two strings is only 2. Okay, like that. So, directly can go to the input. He told that the first line of input will contain a single integer t denoting the number of test cases, and each test case contains these three lines. And that first line indicates the two space separated integers n and m, length of string A and length of string B. Oh, okay. And second line of contains the string A consisting of n lowercase English letters, and third line contains a string B consisting of m. Okay, so we actually first take the number of test cases. Okay, next we have to, for each test case we have to take n and m. Okay, n and m, and now we have to read two strings s1 and s2. So as we have to read, scene S1 and S2. Okay, now we read strings also. Now we have to check the Hamming distance between these two strings. So it must, before going to write the program, we have to look at the constraints. Then only we can solve that problem within given time complexity range. So here t must be less than or equal to 100 and mn must be also less than or equal to 100. B and A contain only lowercase English letters, that is the characters and A through Z. So we don't need to bother about the third constraint, but about two constraints we have to take care. So uh, there is like these two constraints told that we have to take like it is enough to take integer data type for those variables for t and m and variables. Okay, that's what I did. Now we have to Hamming distance. This is just a shortcut and Hamming distance. We have to give S1 string and S2 string and end of line. Okay. Now this is the function which returns Hamming distance. Hamming distance and string sorry string S1 string S2. I think we need to send these N and M also. So int N in M. Okay. So here the M length and length of first string and length of second string. Okay. So here we have to find the Hamming distance. So before finding the Hamming distance, we have to observe the output. So here output is storm and woods. So folks paint. So basically he told orange and apples. These are strong words. So which one? So but if you take a first test case, strong, strong and woods, woods, yes, woods. Okay. So uh, here we have to compare the first character and of the first string and second character of the first string. Yeah, okay. If both are equal, from that we have to increment the distance, Hamming distance, where uh, the characters of these two strings are not equal. As this s not equal to 0, so we have to cancel this. T not equal to 0, cancel this. But O is equal to O. So from here, we have to calculate the Hamming distance. Uh, we know that how to calculate the Hamming distance. We have to increment the Hamming distance. Uh, it is actually equal to 0. So we have to increment that Hamming distance. Okay. Uh, where we got where we will get uh, uh, not same characters in these two strings. S R are same, but M Z not same. So Hamming distance is incremented to 1. Is it? So the result of test case is 1. That's okay. So now we just we have to transfer our intuition, this intuition into a code form. So how can we do? So as we have to iterate throughout the loop, but here there is uh, another option, right? So for these string, we know that this string present or not. It may be present or not. We have to know how many chances for the string to have how many chances that string to have to be placed in string one, right? So let me clear this. Mm, okay. So uh, s- this first string has actually right. This first string has actually length of uh, five, right? And this second string actually length of three. So now this second string uh, which has length 3 have 5 of 3, right? So like 5 minus 3, not sorry, pardon me. So the second string has 5 minus 3 of chances that to be placed in this first string, right? So uh, this like let me clear this. So this is has length 3, and if you take the string first string, so it may be here. Don't bother about the characters, just think about the places. So this second string has 3 places, and this first string has 3 places. So our string satisfied. If this is not the one, so uh, 1 2 3, this is the second way. If this is not the one, this is 1 2 3, this is third way. So how many ways we have? 3 ways. 5 minus 3 is actually equal to 2, but we have to calculate it from 0. So 0 1 2, total 3 ways. You got it? You got it. I think you are good. Let me take another example. So let us take okay. So see oranges. Okay, oranges. N G E S, and apples. A P N E S, apples. Right. So this has three trees. This has length 7, and this has length 6. So number of ways that the second string to be placed in the first string. We have to differentiate those two strings. We get one answer which tells about the number of ways that second string has to be present in the first string. So here we got 7 minus 6 is equal to 1, as we have to calculate from 0. So 0 1. So there are 2 ways for these apples string to be placed in the first string. So 1 2 3 4 5 6. Okay, this is one way. And if you calculate some for second position, 1 2 3 4 5 6 as 2 ways. If we calculate from third position, 1 2 3 4 5 6, we need another character, but we have reached out of string, so we have only gotten 2 ways. So this is about the intuition of problem. So now, so we have to first find number of ways. So in number of ways that will be present in number of ways second string present in number of ways or second string is equal to n minus m. So now we have to write loop up to this number of ways equal to 0, I less than equal to this number of ways first thing to and I plus plus. Okay. So in this loop we have to calculate like distance, Hamming distance. We have to take initial Hamming distance as Hamming distance, equal to, we have to find the minimum. So he asked us find the minimum Hamming distance. We have to initially use max. Okay, x into max. Okay. So now from here we have to take distance. Like it's our choice, but uh, throughout this first iteration, we have to find the first possible way of string 2, which is in string 1. So how can we do? We can do that with the help of these option, that is a string here, string 3 equal to s1 of sub substring of from position I to do what is the length of that substring? Yeah. So okay. So this is about getting the new substring from this string s1, which we thought it is same as s2. So we have to iterate this substring. Okay, you know that length is equal to uh, m. Okay, now so sorry. Here we take variable as p. So now how to check whether the we have to increment the distance value when we got different characters in these substrings. Okay, so and this one, got it. So if we get a different characters, we have to increment. Actually, okay, yeah, string, right? String to not string. So okay, we have to increment distance value. So distance value, it is changed uh for ways. So for first ways, it has to be initializing uh equal to 0. So now we get the distance value. Once we get the distance value, we finalize that Hamming distance equal to enough Hamming distance and this distance, right? So once we get, we have to return that Hamming distance. So see, this is the approach. Let me check whether it is right or wrong. Substring, why it is wrong? Was two as long string. Okay, okay. We are the spelling. STRM string, right? Mm. Oh, here Hamming distance HDD, not NVD. One thing, I think it is same. Is given distance. Right. So submit. Yes, our submission is right. Now let me try this problem. Actually, finish this some also third problem also, but it is out of time, so my submission is not valid. But I understand this redundant array. So here chef has an array which contains n positive integers. He can perform the following operations any number of times. He choose the L and R integers and he take the positive integer between those integers and he set those positive integer for from L to R. So in order to do this, he needs a cost. Cost is R minus L plus 1 dot x. So if you carefully observe the outputs, like see, um, yes, we did the uh, problem statement. After problem statement, we have to read about the form. So here we have to take a t integer, so it depends on the test cases, and each test cases has these cases. Like we have to take n, and we have to initialize that. We have to add a when positive integer, and we have to output a cost, which has minimum cost. Okay, so it has 2 into 10 to the power of 5, which crosses the integer integer data type. So like if we take integer data type, it causes overflow. So we have to take a long. So LL defines long, long, long. Okay. Now, so uh, for three test cases, and first test case has 5. So 2, 4, 3, 5, right? Yes. Yeah. Now, an array which has length 5 of elements which has positive elements, of course, 2, 4, 3, 2, 2. So 2, 4, 3, 2, 2. So this array has length 5. Okay. So we have to return the minimum cost. And we have to do a process, certain process, which makes this array completely turns into a, which makes that array, which makes that array, which makes that array to have equal elements. So whether we see, so if you want to make this array e with equal element 2, how many operations we have to perform? So as here 2, 2, 2, this length is 5. So 5 minus already 3 places occupies 2. So we have to perform 2 operations on it. But if you want to place 4 as the equal element throughout this array, so how many operations we have? 5 minus yes, 5 minus 1. 5 minus 1, the result is 0. So 4 operations. We need 4 operations. We have to perform that. And even if we have, if you uh, want to this 3 be the equal element throughout this array, so 5 minus 1 again. So again we have to perform 4 operations. So it causes some more cost. It also causes more cost. So 2, this 2 element is the right choice for us. And according to him, we have to select these L and R. This is the left one and this is the right one. So when we select L and R, so this position value 0, 1, and 2. So this according to him 2 minus 1 plus 1 into that element. What element we want to be in that equal array. So the result is equal to 4. 2 to 2 to 4. What is wait. Let me explain this clearly. So he gave that R minus L plus 1 into element. X is the element we thought. Element which makes that entire array into equal. So this R array has actually right side and this is one is left side, plus 1. So it actually talks about the size of the uh, array which we are replacing with these elements. So he given that. So this is the size of the array, and we have to replace these element in this size. So if we take this size, we have to replace that element, these elements with these element. So 2 2. So result costing in which results costing in 4, right? Right. So let me do this. Let me put my thoughts as as so the okay, seen size after that we have to pick an area of size. That's amazing common for kids. Yeah, guys, we're taking that out. And we have to take this area of length. Oh, we forgot it has constraints 10 to 10 to the power of x. So that means we have to take long. Right? See, long. See, this area also long. Because we don't know. He clearly constraints. He mentioned that in constraints. Has to be 2 to 10 to the power of 5. So, makes sense. So, our approach. What is our institution? We have to find the minimum cost. Uh, it is 243. So, we forgotten that n minus k into element. This is the element which you replace, and this is the size of the, and this is the number of elements of these element, number of elements of this particular element in this array. Okay. Then we get the number of positions which doesn't have these elements, and we place these elements. And when we place these elements, we got okay, these number of elements we place, we got the size, and we have to get the minimum cost for that size. Okay, so for that we have to take a map, because why map? We want to calculate its frequency, right? Okay, so frequency, and let us start. And less than 5 plus plus. So we have to create this map with particular element, and if we get the same element, we have to increment element position. Okay. So now we have these frequency elements. We have to iterate over these map, and we get the result. But okay, it is better to iterate over this map to get the result. So in I is equal to xp dot angle. So as it is an iterator, we have to put auto data type. Okay? We have to say that I is not equal to the end of the line. Or else you have to implement. Okay. Now, so as we have that, we have how to get that element. So I plus we get first element, and for second position element. So I yeah, this is for second position. Okay. So answer, we have to take answer as n, because uh, like if all elements are different in that array, we have to change the entire elements to a particular element of that array. So the maximum size must be n minus 1. So it's better to take n. Now this function has to be minimum of answer, and we have to do this and minus same elements. So frequency into that element ratio, right? So here we get f as minimum and we can return that answer. So let us see. Use right now. While okay, I have to increase my speed by maintaining the correct s- without maintaining spelling mistakes. We actually CD fine. Right? Oh, okay. What is this? I express cannot going to be used as I have a looking knowledge, right? Mhm. Expected comma before answer. Okay, I'll take it. Oh shit. Oh, okay. I think it will be right now. Okay. And no match for operator. Oh, okay. This is space time. See how it has to prove. Okay, I see. There is no and we have to write and I'll write. So now it will be right. We'll get the answer now. C405, right? So we can submit our code. Yeah, this is my um, first participation. This is not my first participation in codechef contest, but I have to improve. So further, I'm recording my problem solving skills.